This conference will now be recorded.
Hello, I think we're ready to go. So first of all, I want to thank everyone for being with us on this rainy but still beautiful day. And we really hope that you, your family, and your loved ones are safe and healthy during these challenging times. So welcome to our first webinar of the year titled Introduction to FISP. This time, we will be focused on facade inspections. We will be presenting a significant amount of information for approximately 45 minutes, and then we will answer any questions you may have. So please note that this presentation has been copyrighted, but if you would like to share it with your friends or colleagues, just send us an email. We're happy to share it. We just want to make sure that we know where the information is displayed. Also, please note that this presentation has been based on some of our private projects. Therefore, the information should not be taken as code or replacement of a building rule. So my name is RAUL. I'm a licensed architect registered in New York and Florida. I have over 12 years of experience in building envelopes. Before founding M+S or MAYTARA Sebastian Architecture, I worked for 3 different firms specialized on exterior restoration, where I was able to gain a large number of experience working on historic and modern buildings. Wanted to share with you some examples of projects I completed in the past. You can see they involve buildings with red common brick, stone decorations, some buildings with terracotta, and some more modern buildings with window wall, curtain walls, and also rain screen systems. As my role at M+S, I'm the principal architect and also the QE for all our restoration projects. We currently have projects on the 5 boroughs and also some New York State counties. I wanted to share with you 4 of the properties that we're currently working on. First, we have the one of the churches, and in my opinion, one of the sexiest projects that we have is 135 West 4th Street, located half a block from Washington Square Park. At this building, our firm completed restoration of the off-street facades in order to resolve moisture infiltration. This year, we have been approved by Landmarks and DOB to complete the restoration of the front facade, which is constructed of Tuckahoe marble, white Tuckahoe marble, the material used at the New York City Library and also Grand Central Station. The second project we wanted to show you is the Novotel Hotel, few blocks from Times Square. At this building, M+S completed the FISP inspection in order to file the 8th cycle of the building. The building was classified as SWARMP. This means that the project will have to, the building will have to go under some repairs in the next 3 years. The third building on the screen is a project located on 56th Street. This is one of the 4 attached buildings included in the property. At this building, our firm completed a repair program that addressed severely deteriorated stucco conditions. So part of the repairs completed included brick replacement, stucco repairs, stone patching along the window headers, window sills, reinforcement of the fire escapes, and also reinforcement of the metal cornices. Last, we wanted to show you one of the complexes that we are working on. This is Cambridge Hall Condominium in Queens. The condominium is composed by 3 large buildings housing approximately 300 apartments. At this property, we have completed facade buildings, roof repairs, garage reinforcements, pavement replacements, and we're currently working on sidewalk and walkway improvements. As building architects, we also review all the proposed plans for interior renovations. So building facades, as you know, are in permanent contact with the public and the exterior environment. As one of the most important instruments of presentation to the exterior world, facades, in our opinion, should articulate a respectful relationship with neighboring buildings, a desired aesthetic, but also, and above all, it should express and guarantee its safety. Safety is the key and the magic word for us when we're handling facades. So as we will learn today, FISP is really a result of several fatal accidents. We wanted to show you two accidents that, in our opinion, could have been avoided. The first one occurred back in August of 2013 and involved the resident of an 11th floor apartment at 57th Street. The resident of the apartment was casually smoking a cigarette and decided to sit down on the top rail of her balcony. Unfortunately, the balcony could not take the load and collapsed into the street. The second accident involved a 60-year-old architect, a pedestrian, this time not a building resident, who was walking near Times Square. The accident occurred back in 2019 and it was caused by the dislodgement of the terracotta section from one of the lower floors in the building. Now, as mentioned before, both accidents could have been prevented. In the case of the balcony, the building was supposed to file the FISP report 3 months before the accident. On the second example, the building had been issued a Class 1 violation back in April, so almost 9 months before the accident. Despite the violation, the owner did not take action in installing a sidewalk shed along the perimeter of the building. So, what is FISP? FISP stands for Facade Inspection and Safety Program, and it was previously known as Local Law 11. So it is a law that is aimed to ensure the public safety and structural stability of buildings in New York that are taller than 6 stories. The 6-story application includes 6-story buildings with a basement but not with a cellar. This application is regardless of the information in the certificate of occupancy. So if owners have a building that is 6-story tall, plus a bulkhead or plus a penthouse, and they're not sure if they should be filing a FISP, they could ask an architect to file an HB or high verification form. This form will be reviewed by the DOB, and the DOB will determine if your building should be subject to FISP or not. Please note that the DOB has a tendency to welcome every building to their FISP world. Therefore, you want to make sure that you want to ask before you submit this filing. So what happens with buildings that are shorter than 6 stories? Well, they're not completely off the hook. The New York City General Administration rules mandate that the owners have to maintain their building structures in safe conditions. Recently, we have seen several violations for failure to maintain buildings on buildings that are only 3 or 4 story tall. So, what buildings on this slide do you guys think it could be subject to FISP regulations? As mentioned before, 6-story buildings with a basement will have to file a FISP report. Also, buildings that are taller than 6 stories, so building C that has 7 stories should be filing. And lastly, building number D, building D, although it may seem like a 5-story plus a penthouse on the certificate of occupancy, if you look at the number of levels on the back side, you will see that it should really be considered a 7-story building. Therefore, it should be filing a FISP report. So FISP was established as a consequence of an accident that occurred back in May 16 of 1979, where a woman attending Barnard College was fatally struck by a piece of terracotta that fell from the 11th story of the building at 601 West 115th Street. As a consequence, Mayor Ed Koch signed Local Law 10, and this was the first law that required buildings greater than 6 stories on the 5 boroughs to file a report every 5 years. This initial rule had few exemptions. For example, buildings and upper sections of buildings with a setback greater than 25 feet were excluded. Also, only visual inspections with the use of lenses or binoculars was sufficient. Hands-on examinations were only encouraged but were not required. So through time, FISP has become more strict. In 1997, a series of collapses led to the change and the deletion of the initial Local Law 10. So in 1998, Mayor Rudolph Giuliani passed Local Law 10 into the law. This new law removed all the exemptions of the previous Local Law 10 and required hands-on examination, finally. In 2010, the program in its 7th cycle was renamed FISP, and this is the way we know it now. During this change, staggered filings were introduced. We will go over the staggered filings later, but the goal of the staggered filings was to avoid over 14,000 building reports filed at the same time. So in May of 2013, a renewed focus was passed. A renewed focus was implemented on balconies and railing inspections. This change was issued due to the accident that we reviewed earlier. In 2016, all FISP reports were required to be filed electronically using the DOB Now system. Additionally, a QoS certification was added for professionals filing FISP reports. One of the latest changes that happened this year, and it has been giving the owners a lot of headaches, because the number of close-up inspections per building has been significantly increased. Additional experience is now required for professionals filing reports. The report status at the end of the inspection has to be posted inside the building lobbies. Evidence of close-up inspections is now required for to guard against false filings. DOB has also significantly increased civil penalties. And FISP reports for cavity walls now must include proofs. So when do you need to file your FISP report? Owners of buildings subject to FISP must file and have their buildings inspected every 5 years. The inspection deadline is based on the building's block number. So we're currently working on the 9th cycle. We have completed 8 cycles since 1980. And as mentioned before, each cycle is divided or staggered in 3 subcycles, A, B, and C. So once you know your block number, you should pay attention to the last digit of the block number. Since we are on April of 2020, and if your building's last digit of the block number is 5, you should be subject to the subcycle A. Therefore, you should be filing before February 21st of 2022. We strongly encourage building owners not to wait until the last month before filing or doing the inspection for the reports. This is for 2 reasons. First, you want to avoid late fees because the review of the reports may take 1 or 2 months, and you want to have the proof report before the deadline. And also because inspectors may find issues with your building that you may want to address before filing the report. All the information included on this presentation is mandated and detailed further in the section 103-04 of subchapter 1 of chapter 1 of the rules of the City of New York. So who can file a FISP report? Since 2016, FISP reports can only be filed by QEs. QE stands by Qualified Exterior Wall Inspector and is an architect or a professional engineer with at least 7 years of experience handling facades. This experience is verified through a DOB interview and a testing process by the DOB Commissioner. So please note that not architects or engineers are QEs. So why is it important to select the right QE? In our opinion, you should select your QE as you select your personal doctor. Your QE should demonstrate relevant experience with the facade system of construction type specific to your building. This means that if your building is made out of brick and terracotta, the QE should show you projects completed on those systems. If you have a modern building that is all window wall systems, the QE should have completed projects with those systems too. And also, you should make sure that your QE is very involved during the interview process. Talking about involvement, I wanted to show you an unfortunate accident that occurred back in 2011. A professional engineer classified a building on the Upper West Side as safe. However, 6 months after the approval of the report, a terracotta window sill collapsed and killed a 2-year-old girl. The DOB investigation determined that the engineer did not even visit the site. So, yes, the DOB allows architects to work with QEs as consultants, but you want to make sure that the QE is very involved during the process. You want to meet the QE, and also you can now verify that the QE is certified. There is a list available online to see every QE that has been approved by the DOB, and the link is shown on the bottom of the screen. So every FISP cycle will have 2 main components. The first component will be the inspection program or the field work that will be done at your building. And the second component will be the report writing, and it will be done at the architect's office. The first component has to be designed by the QE specifically based on the type conditions of your building envelope. Also based on the age of the materials, the facade exposure, and the present or any specific detail or appurtenances. Consideration should also be given to the history of maintenance and repairs described on previous reports. And additionally, it's very important to be aware of any water leaks that the building may be experiencing. The QE during this inspection must order access to terrace balconies that he may need require in order to review the entire facade. The QE will also request the owner to conduct additional field tests in order to determine the structural stability of some building components. The slide shows 3 of the most common mobilization systems in order to review the facades. First, we have the rappelling that is commonly used for buildings that have complicated roof configurations or whenever the roof could not support the heavy equipment required to the installation for scaffolding. Second, we have the aerial work platform, also called the boom lift. That is personally my preferred method because it's very safe. It's mainly used for buildings up to 15 stories, and it allows the detailed review of very wide facades. You could park the boom truck in the middle of the facade and extend up to 75 feet horizontally both ways. The truck comes with a certified operator that will give you a ride on the basket for up to 8 hours. So if you want to avoid going through apartments to review railings or going to terraces, the boom truck should be your preferred option. The third option is the most used and it's called the suspended scaffold platform. In this system, the platform will be suspended on cables that are attached to the parapets or to outriggers. So in order to set up this equipment, the workers will need access into the building and they'll have to place significantly heavy weights over the roof. So if your roof has pavers or if your roof has planters, this system may be a little difficult. So the examination has to be completed in a path from the grid all the way to the top of the exterior wall that is fronting each public right-of-way. As shown in examples A, B, and C, this can be achieved in different ways. Your QE may want to use a scaffolding from the ground floor all the way to the roof, and then he may want to just walk the roof to verify compliance on the parapets or conditions on the bulkhead. In example B, we can see that the QE could also achieve the full path by accessing every balcony if you have balconies all the way up to your main roof. Finally, we see building number C, where the QE has conducted examination by using a combination of scaffolding and then accessing the terraces. If your facades that are off-street and they're in good condition, the QE may want to just use binoculars to review the facade and access will not be required. The use of drones and other methods are encouraged but are considered only supplement to the close-up inspections. They do not eliminate the requirements for hands-on inspections. The number of examinations per facade has also changed this year. DOB now requires a minimum of 1 examination every 60 linear feet of facade. So if your facade is 70 feet wide, like the image shown on the screen, you will need 1 examination for the first 60 feet, an additional examination for the last 10 remaining feet. We included a table that you can use to determine the number of examinations. So if your building, for example, is 150 feet wide, you will need up to 3 examinations. So for irregular facades, this includes facades that have setbacks or facades which heights may change may vary throughout the property line. You have to apply a few different formulas. If your building has setbacks, you should add the length of the facade that is facing the street and also the length of the sections that are perpendicular to the street. You add up these sections and then divide it by 60 to determine the number of examinations. If your building has irregular heights, you should only be measuring the sections that are higher than 6 stories. Add up those sections and then divide it by 60 in order to determine your number of examinations. Another new component of the report will be probes. Probes should only have to be performed if your building has cavity walls. So the number of cavity wall or number of probes has to be determined by your QE, but please note that you will need at least 1 probe every 60 feet. The goal with the probes is to determine the spacing and the conditions of the cavity walls. This requirement was due to recent failures on cavity walls that were caused by missing or deficient wall ties. Thankfully, most of the probes are considered minor work, unless your QE decides that he wants very large probes, which at that point you may need to pull out some work permits. So during the field work, and at the end of the field work, your QE should give you a call and let you know that your building will be classified unsafe, safe, or SWARMP. We will explain those classifications now. Unsafe is a condition of a building that is hazardous to the public and requires prompt repairs. In addition, it's any condition that was previously reported SWARMP and was not repaired according to the timeline provided by the QE. We wanted to show you some examples of unsafe conditions. As you can see, the stucco on the left, the terracotta on the middle, and the brick on the right-hand side are in very bad shape to the point that we could remove them manually. These photos were taken during my inspection on a building located in Chinatown. Unsafe conditions must be corrected within 90 days from the date of DOB notification. Of course, 90 days is unrealistic most of the times. Therefore, DOB allows extensions. The first extension is typically approved for 90 additional days, and DOB will have no problem approving them as long as you prove that you have provided proper protection. So sometimes you will need to report the unsafe conditions, and they have to be, most of all the time, you need to report unsafe conditions, and they are typically they can be reported by calling 311, 911, or filing a FISP 3 form. The filing of the extensions are conducted by the FISP 1 and the FISP 2 forms. So I wanted to show you additional conditions, unsafe conditions found on other projects. We see a piece of terracotta that is dislodging at the landscape at the fire escape landing. Also sections of stone bricks along the window headers that are about to collapse. Finally, the stucco sections that have shifted. I know it may look like brick, but it was actually stucco. And unsound sections of brownstone patches that were about to collapse. Sidewall sheds is the most common method to provide protection in unsafe buildings, and they must remain in place until permits are signed off. The FISP report has been approved by DOB. Yes, under certain circumstances, the QE could file a letter and request the partial removal of the shed. However, you run the risk that the DOB may object the report, and then the owner will have to pay to have the sidewall shed reinstalled. Additional images shown at more unsafe conditions. We see a large stone crack previously repaired with caulking that is about to collapse. Some balcony ceiling sections on a building located in Queens, Chinatown, that it was also about to collapse. And one of the most scary conditions that I've seen lately, it was a facade that it was bulging on a 3-story building located in Brooklyn. This was caused by a structural movement of the foundation walls. The second type of condition or classification that you may find during the inspections are called SWARMP, or safe with a repair and maintenance program. This condition means that the wall or parts of the wall was found safe at the time of the inspection, but require repairs or maintenance during a time frame to be established by the QE. So if you don't conduct these repairs, the conditions will get worse and develop into unsafe conditions. We see 3 examples. The ones on the left and the right include lack of caulking, If you don't put the proper caulking on the windows, you first will be causing moisture infiltration and then deterioration of the adjacent masonry. So due to freeze-thaw cycles. If you don't put the caulking on around the railing post, the underlying structure or railing anchors may deteriorate and the railing posts will start to move in few years. The image in the middle shows a hairline crack developing on the roof side of a parapet wall. During my review, I sounded the adjacent areas and determined that the brick and the mortar were sound. Therefore, it should be repaired, but it was not an emergency. Also, I consider that the crack was only shown on the interior side of the parapet, not on the exterior side, facing the street. Additional examples of SWARMP conditions shows some hairline cracks along window lintels. There are precast made out of precast concrete. In our opinion, those hairline cracks should be sealed or coated in order to prevent moisture infiltration that will cause freeze-thaw cycles in the concrete. Also, if the mortar voids shown on the image to the right is not repointed, it will be causing moisture infiltration in the wall and potential movement of the bricks. As noted below, the owner is responsible for ensuring that SWARMP conditions are corrected and reported to the DOB within the timeframe recommended by the QE. The last type of classification that your QE may give your building is the safe. Safe is a condition of a building that does not need repair or maintenance to sustain the structural integrity. Therefore, your building is fine and good to go and for about 5 years until the next cycle. We wanted to show you some images of safe buildings, one cladded in stucco stones, one cladded on brick and terracotta, that achieved the safe classification upon completion of a repair program by N+S. In our opinion, you should always be able to maintain a safe status as long as a competent QE has established a maintenance program that works within your budget. Yes, that means that you may need to do maintenance, but maintenance will always be cheaper than doing large comprehensive repair programs at every FISP cycle. So let's assume that your field work has been done and your QE knows what status will your building have. Then he will go to his office and start typing the report. The report will have a large amount of general information such as address, block number, PIN number, landmark status, location of nearest streets, also some information about the owner, such as the name, mailing address, telephone, description of the building, meaning the height, plan dimensions, use, type of what construction, and some of the most important information includes description and photographs of any distress, of the procedures making critical examinations, and also classification, quantification, allocations of any safe with rate, any SWARMP item or unsafe elements. The report should also include information regarding active water leaks. Water leaks most likely trigger a SWARMP condition. Finally, it should include recommendations for repairs and deadlines to repair SWARMP items. The report can only be filed after the QE and the owner have signed the report. So there is a need for certification by the owner indicating that he or she has reviewed the report. The owner will need an e-filing account in order to process his signature. The report status will depend on the most hazardous type of condition found during the inspection. This means that if your building is mostly safe, but it has one or two SWARMP conditions, your building will be classified SWARMP. If your building is mostly SWARMP but has one unsafe condition, unfortunately, your building will be deemed unsafe. So there are three types of reports that may be used by the QE depending on the timing of your filing. The first report filed by the QE at each cycle is called the initial report. The subsequent report is used by the QE to change the initial status of the building. This is typically filed to achieve safe status once SWARMP items are repaired or to downgrade SWARMP items of buildings that have degraded over time. Finally, an amended report is used by the QE to certify that unsafe conditions have properly been addressed. The related DOB filing fees are also shown on the screen, and they're typically paid by the owner. So how much does a FISP inspection could cost? Again, please look at this screen and understand that the costs are limited to the inspection, not to the repairs yet. Owners should consider two main elements of cost. First, the professional services, which are the fees that will be charged by the QE and are limited to studying your building's history, conducting the building inspections, and preparing the FISP report. If a repair program is required, these fees are typically additional and may range between 6 to 12% of the final construction cost. So professional fees limited to the inspection will range in price, and it will depend on the size of the building, facade details, number of balconies or setbacks or terraces that need to be reviewed. Of course, if your building is very large and complicated to access, the inspector will spend more time. It will also depend on the records available by the owner or management. If the owner or management don't have copies of the previous report or are aware of any issues in the building, then the QE will need to pull copies of records from the DOB and probably, this is something our firm always does, conduct surveys among the residents in order to see if there were any failures or water infiltration issues that were not reported. The fees for professional services will also depend on the QE's firm. Larger firms, due to overhead, will tend to charge more, probably up to 30% more than smaller firms. So for buildings between 6 to 10 stories in height, fees may range between $4,000 to $8,000. For buildings between 10 to 30 stories in height, fees may range between $5,000 to $10,000. The second section of the cost will be the contractor fees. These are fees charged by the company who will supply, install, and operate the equipment to be used by the QE. Yes, the QE cannot fly yet, no. So we need someone to take us up and down along the facade. So the fees, in case the QE wants to use a boom lift truck for buildings between 6 to 10 stories, may range between $7,000 to $10,000. Fees for the buildings of the same height, but this time using a scaffolding, suspended scaffolding, may range between $5,000 to $8,000. Please note that the cost shown on this slide assume that no probes will be required, and also DOB filing fees are not included. Probes requirements will probably double the total fees of your inspection. Now, to complete this presentation, we will show you 4 elements of concern. As you see, if your building have any of these elements, please don't freak out, don't be scared. This just means that you need to monitor the elements and you need to have a closer look at every FISP cycle. The first element of concern is terracotta. Terracotta is Latin for cooked earth and is a mix of clay and sand molded to complex shapes, glaze, and then fire at very high temperatures. We have an example of terracotta ornaments on the screen. As you can see, you can achieve very complicated shapes and it looks beautiful. So terracotta was selected during the 19th century, but mainly due to its aesthetics and relative fast production. Now, with that said, as you can see, it was not selected due to its longevity or strength. So terracotta, once loses its glaze, becomes very porous and is subject to freeze-thaw cycles. As we can see on the sections to the left on the center image, terracotta sections are usually composed on smaller segments. Therefore, you will have joints that may cause moisture infiltration into the backup structure or backup masonry. Also, as you can see in the section, terracotta is not solid. It is hollow. They are pretty much hollow clay masks. Terracotta segments, therefore, are not structural. Its deterioration may result in spalling, dislodgement, or collapse of the segment, which always or typically causes moisture infiltration, structural deterioration, and interior damages. Some examples of terracotta failures. The one on the left was located, believe it or not, directly above the main entrance of the hospital, located in Staten Island. As you can see, the terracotta section along the window header is cracked and about to dislodge. Needless to say, we recommended the owner to immediately install a sidewalk shed along the main entrance. The second image shows terracotta failure along a corner, and you can see some previous repairs conducted with regular cement or even caulking. The last image shows terracotta failure and the rusting of the underlying steel and anchors. So monitoring, maintenance, and repair with adequate materials is required to prevent accidental spalling and collapse of terracotta segments. So we've seen terracotta very involved since the beginning of FISP history, and this is essentially because terracotta are large and thick ceramic decorations hanging hundreds of feet above the street. Again, selected due to aesthetics, not due to longevity. So an additional element of concern when you're dealing with facades are fall protection systems. The DOB rules mandate that the QE inspects balcony railings, guards, or fences to ensure that their components are positively secure against any movement. The QE will have to verify that all the welds, screws are in safe conditions so your railing is not deflecting or moving. As we can see in the images, we see a railing post that has been significantly deteriorated, and it'll probably require installation of a new plate on the bottom to secure it properly. Then we have a missing fence panel on the roof. It was temporarily patched with a fence, a chain link fence. Unfortunately, the temporary work has been there for 6 years, so the building had to be deemed unsafe. Last, we see a parapet wall with a railing, with a top-mounted railing that is under review for the height. Typically, the height for parapet and railings have to be 42 inches from the adjacent walking surface. Now, this height has to be in respect to the code in effect at the time they were installed or substantially altered, substantially modified. So any railing that is not positively secure must be classified as unsafe or made safe in accordance to the procedures required by the rule. So as mentioned before, the QE may also request field tests to verify that the railing complies with the required load by the building code. So the load for railings is 200 pounds when they're applied at concentrated sections. Next element of concern is glass. Glazing can be found on windows, doors, railing panels, and if they are present in walls, they will be in the shape of window walls or curtain wall systems. Glass damage can be caused by improper design of the support system, defective fabrication, defective installation, or sometimes due to impact while it is being maintained, as in the image shown on the left. The image shown on the middle shows a shifted section due to the failure of its supporting system. And the image on the right shows a missing panel and that it has already been dislodged due to the failure of the hardware. So due to its nature, we strongly recommend that the owners review the glazing components before and after any maintenance, because damage can be caused during the mobilization of the maintenance equipment. The last element of concern are cavity walls. Cavity walls are a type of wall that consists of two layers, separated by a hollow space or cavity. The layers are connected by metal wall ties. Cavities can function as a drainage plane, allowing any water that has penetrated the veneer to drain to the bottom, where it encounters flashing and is directed to the outside through weepholes. We see the two layers on the image shown on the right, and we see how those layers are connected with cavity walls. We can also see that if wall ties are affected by moisture infiltration, they could expand and cause movement of the outer veneer. The inner section of the cavity wall could consist of metal framing as shown on the image on the left. It could also consist of CMU blocks as the image shown on the middle. Please note that cavity walls will only perform well if proper support is provided, as this is usually achieved by an installation of relieving angles shown on the bottom of the image on the left. This is the relieving angle. And it will also perform good against drainage, if proper weep holes and drainage mats are installed. This is rarely achieved and observed in buildings throughout Manhattan. So cavity walls were not all bad, as they were designed in order to achieve good R values and also to resist wind-driven rains. Some examples of cavity wall failures, as you can see, the example on the left, the failure was caused due to missing wall ties. You don't see any wall tie at all. The example on the middle, you see a very small amount of wall ties. And wall ties by the building code should be installed at a spacing no larger than 24 inches apart. This specifications should be confirmed by the QA using the original construction plans for the building. The mechanical pinning process shown on the image to the right is used in order to stabilize the outer veneer. This method should be designed by your structural engineer, helping guiding the QA. While it addresses the structural movement, it does not prevent moisture infiltration or improve the insulation of the wall. So where do you need to file your first FISP report? This is typically asked for newer buildings. You need to file your first FISP report 5 years from the date of your first certificate of occupancy, only if the date falls between your filing window. And then we know this is based on your block number. If that date falls outside of your filing window, then you just need to wait for the next FISP cycle and then file it on your applicable filing window. So please don't wait for your first FISP cycle to do a comprehensive review of your building. If you have a new building, we strongly recommend owners to conduct the first review before the statute of limitation expires. Please don't wait until the first FISP cycle, because this may come 10 years or sometimes many years after your first certificate of occupancy. So the statute of limitation for contracts range between 3 to 10 years. Really, they're typically 5 years in New York. And this limits the claims for defective construction. But so if your QE finds defective roofs or defective facade systems, you could not initiate any claims if the defects are discovered after your statute of limitations has expired. Now we will open the panel for some questions, and then if there are no questions, we will over our closing comments. Thank you very much for your attention, and now we will proceed with the question, which will be read by my partner, Hannah Sebastian.